Now let's get started into the second hour, and I have shown you in the first hour how you can set up the project, and my main goal was to show you how you can create a class library where you can add your entity framework stuff. We didn't do that in the last year, so you see there is a difference between the 4th grade and the 5th grade because now we take a look at more complicated setups. I have created for you the entire the entire data model in this sample solution. It's not the best solution, but it's a decent solution for this size of project. I don't want to overcomplicate it, but still it has a certain level of complexity. Let's take a look at some typical things that I did for you here. As you can see, this is the complete user entity. It is not 100% identical to your entity relationship diagram that you created last time, but it is nearly identical. The first thing, what I typically do, and I really do that also in real world projects, in some way or another, I note the requirements in the code. So typically I do documentation, professional documentation of my classes, and the requirements become parts, integral parts of the documentation. In this exercise, I wanted to make it extremely obvious why I created which field. So what I did is I copied and pasted requirements from the case study inside of the code. That makes the code really easy to maintain, because if at some point somebody asks, why do we have an email address? Then we see, it was part of these requirements. Get the idea? In real world, you also often do not have the requirements inside of your code. But now listen closely, that's important. But you have the check-ins in Git associated to the issues also in Git. So whenever I look at the Git commit history, for each commit, I see the relation of the commit to the issue with the requirements from the end users. Do you understand what I mean? That's extremely important, because believe me, in larger projects where many developers work on these projects, at some point you ask yourself, why the heck did somebody write that code? And then it's important that you can take a look at the history of the code and understand the requirement where this code came from. Because then you can go to maybe the business manager who wrote that requirement and ask, why did you have this requirement? Understood? I don't have a Git history here for this example, so I made it obvious for you and put the requirements directly in the code. In real world, it would probably be the Git history. Now you can take a look at this sample solution on your own. I don't want to go into all the nifty details, but just if we zoom out a little bit more so we get an idea. You see, this is the user class. I know it's small, but you don't need to be able to read the details. This is the user class, but it has a certain level of complexity. And directly below the user class, we have the, see it here, entity type configuration, where we specify the max lengths and the keys and the unique indexes and the relations. Do you see how they belong together? And now you can decide whether you like this one or whether you like the attributes. Both are okay, but this is really very clear. I also have put in a link to the documentation to the Microsoft Docs. If you want to read more about these entity type configuration stuff, follow this link and you will have it. Let me quickly think of what is important here. Now this one is a special one. You've seen it before. It's for a unique index. This is relevant for your exam and for your Matura. I might ask you in the exam or the Matura to create a unique index because it's so common. Therefore, you have to know how to create a unique index. That is important. Okay? I don't care how you do it, but you have to be able to create a unique index. We already talked about the delete behavior. Now we have a user group, nothing special here. This one is something that you might never have seen before. This is part of the Fluent API. With the Fluent API, you can not just define certain data structures, we discussed that last time, the so-called database schema, but you can also define predefined data. Remember what we had in the case study. In the case study, I said users can belong to one of the following user groups: regular share for future employee, manager, or system administrator. So there have to be 3 roles and they have to exist. And with Fluent API, this one, you can specify that when creating the database, the system should automatically create these data roles in the table. This process is called data seeding. So if you look for Entity Framework seed data or data seeding, then you will find documentation about this process. Again, that is data which is not entered by end users. This is data that is part of the basic structure of the database. Understood? And when executing the migration, Entity Framework will make sure that these rows are inserted. They are always present. Fair? Okay? Good. I guess you have never seen that before, maybe or maybe not. Another thing which I added here is the requirement that for each identity, Share for Future needs to store the identity provider. And in this case, I used an enumeration. You probably know what an enumeration is, right? I hope so. Here, I use the enumeration. But in the database, I don't want to store the integer values 0, 1, and 2, but I want to store the identity provider's name as a string. And this can also be achieved using Fluent API by specifying that the enum property has conversion to string. And that will turn the enum into a string representation. So the database contains the word Google for Google identity. Understood? Very useful. With that, it's easy to use enumerations. That is also something that might come in handy when doing exams or the Matura. So remember that one. This is important. Nice. Now, if we take a look at that one, let's go back up here again. I created the user, you remember that? And I said that the user group should, if we delete the user group, we should not automatically delete the users. Now, I'm not sure if I did it correctly. What would you do in order to find out whether we screwed up or whether it works? Many of you would write an API or a console app and simply try it out interactively. We call this explorational testing. Exploratives Testen. Understood? But this is not good. What we should do is what? Write the... You said unit test, but now this is not a unit test. Because in a unit test, you just test the single unit of logic. But here, we want to test whether the database behaves correctly in combination with our code. So we want to do an integration test and not just a unit test. So what we do typically when building databases, we build an integration test. And this is something that I want to show you too. Again, this is probably not relevant for your exam or the Matura, but you want to learn more. You want to learn things that are relevant for the practice, and this is why I want to show you that. What I have done is I have created a regular XUnit test. You have tried that before in the last homework. We talked about it in the past, and I will sneak in a lot of XUnit stuff over the course of the next weeks and months. We will focus on unit testing specifically a little bit later in the year. But still, I want to use unit testing all over the year, so you get a little bit used to it. Now let me show you how you build this stuff. First, in XUnit, you create a so-called database fixture. It's just a name, okay? Database fixture. A fixture, it's called like this. inside this database fixture is just a class. And inside of this class, in the constructor, you just create a database context. That is simple. You all know how to do that. Just create the database factory. We created that together. And create the database context. But now comes the important thing, and I ask you to take a look because that is important, okay? This one. See the ensure deleted and ensure created? Can you guess what these two statements do? The database, not just the table. You're right. You got it. What this thing does, it's dropping the database and recreating it from scratch during a test. So it's going to the database server, dropping the database, wipes it from the disk, and creates a new database, a fresh new database with all the migrations applied. So for your entire test run, you get a brand new copy of the database. You don't care about all the rubbish that's inside of the old database. It's just deleted. So never do that with a production database, because if you run the tests against the production database, your data will be gone. Shouldn't do that. Question? Oh, it's possible with every database provider that I know of. But one important thing here, I have no clue about Oracle. I don't use Oracle. I'm personally not a big fan of Oracle, and therefore I have no idea about Oracle. It's a great database, I heard, but I don't use it. But with Postgres, it works. With SQL, it works. And with many other databases, it works too. Okay? So this is just for your database. And of course, I have inside of my app settings JSON of the test project, you see it here, I have a dedicated test database. Got it? So I'm not using the production database here. This is the reason why in many real-world projects, you as a developer, you don't even have the permissions to delete the production database. Because if you by accident enter the production credentials here, you might want to destroy all your customers' data. And this is not what you want. So therefore, in real life, try to avoid having too much permissions on the production database. Best is, you cannot even see the production database because then you can't screw up. Don't always use an administrator user, which with privileges, that can wipe out your whole production database. Because at one point in time, you will make a mistake and then bad things will happen. Okay, this one is important. Nice, so this is the database fixture. And how do we use the database fixture? Very simple. If we take a look at the user test, this is how you use it. You use an interface and then you get the fixture in the constructor. And just by injecting the fixture in the constructor, the database, the test database is dropped and created. Got it? Understood? Nice, isn't it? And this is what we call an integration test, because the tests will now access a real database during test execution. And with that, we test our C# code together with the database. Integration test. A unit test would be just our C# code without the database. That would be a unit test. Good. Now you see, I wrote a very simple database, a very simple test code. Yes, this is the test code that I want to quickly go through. You see, I create a dummy user, this one. I add this dummy user to the database. I save the changes. Please remember from last year what we did. Then I will remove the user group, see it here. And then I try to save the delete to the database. And that must crash, because I'm not allowed to delete the user group for which a user exists. If I would change this one to delete cascade, the delete would go through and it will delete the associated users too. So this test is verifying that if I delete the user group, the users are not deleted. Understood? So I'm expecting an exception. And I have 3 users at the beginning and I have 3 users at the end. Nothing has been deleted. because I have a foreign key, a relationship, a constraint. Understood it? These are very, very typical unit tests. Let me show you another unit test, this one. I verify that the unique index is properly created. You see, I create a new user, and I simply try to store the user a second time with the same email address. And then again, I expect an exception when trying to save the second user. Understood? These are the kinds of integration tests that you typically write to verify the correctness of your data model. Understood? Questions? Will you have to write such integration tests in the next exam? No. Not yet. But later on in the year, we will deal in more details with unit testing and integration testing, and then I might ask you to write such tests. And now you have an example from which you can copy. Good. I have one last thing that I would like to point out, because everything else is just the same thing over and over again for a larger data model. But there is one thing that I would like to describe. Let me see. Please remember, recall that in our requirements we had so-called unavailability periods. So if I offer my drilling machine for sharing, then I might say, in this week, from Monday to Sunday, I don't want to share my drilling machine because I'm doing a home improvement project. This was the unavailability period. And in the unavailability period, I have a from and an until date. What do you think? Would it make sense if the until date is before the from date? Well, of course not, right? How can you ensure that? You can ensure that by writing C# code, obviously. But I wanted to take this example to show you how you can do that even inside the database. A powerful relational database like SQL Server supports a thing that is called check constraints. A check constraint is an expression that the database checks, and you cannot insert rows which do not follow this check expression. And what I do here, as you can see here, is I'm creating a check constraint inside the database. I say until is null, so if there is no until time, or until is larger than from. This has to be true. If the until timestamp is specified, then it must be greater than the from timestamp. This is a check constraint. This really is written to the database, and you cannot insert a data row that does not fulfill this requirement. That's useful, isn't it? You never have to add a check in your C# code again. It's done at the database level. Understand it? And of course, obviously, I wrote a test for that. See? What I did is I created an unavailability period here where the until is before from. And then I say throw, save changes to make sure that the check constraint validates that the until is after from. Do you get the idea? Did you know about check constraints? Ever heard them? Heard of them? Some of you? Maybe some of you. It's super useful. It's really, really useful. Not every database is capable of doing that. So this is something where you might know, where it might be necessary to know your database and to know whether the check constraints are supported. Question? Yeah. Of course you can do that, but imagine that somebody is using an alternative UI for your database. For instance, maybe they use Microsoft Access. Have you ever used Microsoft Access? They just use Microsoft Access, open a connection to the database and hack in some data rows. If they do that, your C# code has no chance of checking this validation rule. But if you create the validation rule on the database level, even if you use an alternative frontend like Access, nobody can enter invalid data. It depends where you want to have the check. So the answer to your question, can we do that in C# too, is of course you can, but you have to be aware of the limitations. Good? Nice. So this is what I came up with. You have the entire project with the data access layer, with the unit tests, and of course with the application here. So let me quickly check if everything works properly, and we do that by running the tests. Here you see all the tests that I wrote for you, all the integration tests. Let me run them. It will take a second, and hopefully we get a lot of green checks. Yes, looks good. You see, all tests are green. It takes a while. Integration tests are okay if they take 1 or 2 or maybe 10 or 20 seconds. Unit tests should be much faster, but integration tests take a while. What do you think? Could I run these tests, for instance, in GitHub Actions? So on a build server in the cloud? Would GitHub Actions support that? Not like that, because in GitHub Actions, you don't have local DB. You're running on a build server, maybe on Linux. There is no local DB. So do you think that is possible to run such unit tests in GitHub Actions? Yeah. With another connection string, exactly, because in a build server like GitHub Actions, you can spin up, while running your unit tests, other Docker containers. You can simply spin up a Microsoft SQL Docker container in parallel to your test code, and then change the connection string to make your unit tests access the Docker container running SQL Server on GitHub Actions. And with that, you can run integration tests with a database like SQL or Postgres or Mongo or whatever you have, even on a build server like GitHub Actions. I will not show you that now because it would take too long, but I just want to give you this basic idea that Docker containers are the way to go here. So your Docker skills should definitely be good because you will need them over and over again in practice. Fine, this is what I wanted to show you, and I hope that makes the homework much clearer, and I hope this project will also provide you with a nice sample on which you can build for future homeworks, exercises, and so on. Do you have any questions regarding the things that I've shown you in the last, I don't know, 1.5 hours or so?